Hey, good morning. Happy Saturday morning. uh, yeah, this computer crashed like 3 times yesterday, so I lost about 2 hours of footage, but it happens. I'm used to it. Okay, so what we have here, I kind of have to go over this again. Yeah, because computer crashed, it happens. Hopefully it doesn't crash again. My goodness. If it does, I will have to buy a new computer and yeah. But this computer has been working very well for a long time, so. Okay, what do we have here? It's cardinality, okay? So we came up with a different definition of cardinality, not the same as Mr. Cantor did, okay? So here defined it cardinality in terms of bijection and one-to-one correspondence, but that's not a correct way of thinking. Okay, so the way we define cardinality is has to do with number density. Okay, let's say you have a sliding window with fixed length. Okay, so how many numbers are there? Okay, that's how we define cardinality. Okay, so yeah, that's why alpha is cardinality of natural number. Okay, so if you add number, some constant to alpha, it's still alpha. Why? Because number plus 2 is just shifting by 2, right? So if you shift the window, yeah, density doesn't change. Okay, so that's why it stays the same. Okay, yeah, but if you multiply by 2 of the set n, then the density becomes sparser and sparser. So it's half of alpha, okay, because the number contained within the fixed window is half of that. Okay, so it's density concept. Okay, now we are constructing set 1 over n. Okay, it's just distribute that. Okay, so if we do that, then it becomes alpha. Okay, cardinality of 1 over n. Okay, now what if we do this 1 over n in each window, from 0 to 1, 1 to 2, 2 to 3? Then what's the cardinality of that set? Like here, okay. Yeah, it becomes alpha squared. Okay? And here what we have is we apply what's called as a triangular inequality, okay? Just to get some idea, okay? And it works out, okay? Kinda. Why? Because it is inequality. It's just give you upper limit, but we kind of got the idea, right? And we discover another thing. Alpha plus alpha squared is alpha squared. Okay, so that was kind of intuitive, right? Good. And because we are trying to look for the cardinality of rational number, okay, that's a little bit more tricky, okay, because this alpha squared, that's only a subset of this Q, okay. Why? Because in this, we'll call this R set. No, 1 over. We call it H, okay, harmonic set, okay. ZH is a subset of proper subset of the quotient set, the rational number set. Okay, why? Because numerator, I mean, it's in each window, the numerator is always 1. Okay, so it doesn't contain like 2 over 3 4 over 5 or 2 over 5, it doesn't contain that. It's a harmonic set. Okay? So you gotta think about the rest of them. Okay? And my guess is that the cardinality of Q is probably alpha cube, third order. Okay? So this is kind of informal disproof of Herr Cantor's uh, continuum hypothesis. Okay, this is disproof. All right, because he said there's no intermediate between whose cardinality is between the real number and natural number. Okay, and according to him, something like cardinality of real number is like two to the 2 to the alpha, something like that. And he called it Aleph null, but the same concept. Okay, so and we just disproved it. Okay, so yeah. Okay. Of course, we don't have the same definition as Mr. Gero Cantor, but he got the wrong definition. So yeah. Okay. Uh, yeah. Let's take a break, okay? So, yeah. Alright? Hopefully this computer doesn't crash on me again. Oh well. We'll take a break. Yeah. Okay, so because we are dealing with set theory and union, we have to take care of the intersection, right? We don't want to double count, right? But that's kind of detail, perhaps important detail, but we just want to be uh, intuitive. Okay, so let's just look at the big picture here. So I think um, one way to think about it is this. Okay, so you have some harmonic number like 1 over some natural number. Okay, what if to each of them we multiply n? 1 over 2, for example, just multiply, right? That's one way, kind of one way to think about it. Okay, let's limit ourselves between 0 and 1. Okay, and see what happens. Okay. Let's conceive of all the integers, I mean, all the rational numbers between 1, 0, and 1. What does it look like? For example, you have one thing you need to add in order to this on top of this harmonic set is 2 over 3, okay, and 3 over 4, okay, and 5 over 4, okay. So it goes like this. When it comes to 1 over 2, we are adding nothing. When it, when it comes to 1 over 3, we are adding one number, 2 over 3. When it comes to 1 over 4, we are also adding also one number, 3 over 4. Okay. When it comes to 5, we are adding 2 over 5 and 3 over 5 and 4 over 5. Okay. Okay. Shoot. When it comes to 6, we are adding 5 over 6. Okay. Oh boy. Gets heavy. So it actually kind of depends on whether the denominator is uh, composite number or prime number. So it seems. How interesting. So we have harmonic numbers between 0 and 1, okay, and then, but we want to find what we can name as Q0, okay? Q0 is set of all the rational numbers between 0 and 1, okay? Q1 is exactly the same way, so we just need to concern ourselves how many, what's the cardinality of this Q0 set, and we just need to multiply by alpha, okay? Then you have the cardinality of entire rational number set, okay? All right. Okay. We're gonna need to grab another whiteboard, okay? So then let me turn off the heater outside. Okay, let's continue to think about this. Um, all right. Well, let's take a break from this, okay? I read the news. I'm sorry, I was in the bathroom. That in certain parts of the world, including some parts of America, Asians are getting a lot of hit from this coronavirus situation, and I guess some people are just angry. Okay, so then it's I guess they just are looking for some scapegoats. I guess, but well, I I don't know what to tell you. Okay, let's just get along, shall we? Okay. Yeah. I'm sorry about coronavirus situation, but to me, this pandemic is more pandemic of germophobia, okay, as opposed to pandemic of coronavirus, okay, because uh, every year 300,000 people die from common flu, okay, and every year 30,000 Americans die from common flu, all right, so it dwarfs those statistics dwarfs the fatality from coronavirus. So the coronavirus just like any other flu, common cold. Okay, there's nothing different from it. It's just different strand. Okay, so my recommendation: people should get back to work. Okay, and live a normal life. And what should be recommended instead of staying home is yeah, diet, exercise, personal hygiene. Okay, social distancing I think is not too bad a concept, but I mean of course if you're really sick, that's common sense. You should quarantine yourself, alright? But if you're not sick, yeah, you should go working. Why? Because if stop people stop working, I mean they just signed this stimulus package, but that's not a long term solution, right? If people stop working, we'll run out of food, we'll run out of toilet paper, okay? And we'll run out of money too, okay? So it just doesn't work that way, okay? What people should do is go back to work and keep working, keep producing, and keep making money, okay? That's what people should do. Otherwise, we run out of money, run out of food, we run out of toilet paper, and some people will turn to crimes like theft, murder, home invasion. We don't want that. Okay, so stay home, do nothing. The solution is worse than the problem. Okay, the medicine is worse than the disease itself. It will do more harm than good if everybody just stay home and stop working and looking for this stimulus. What, $1,200? What? That's not gonna do anything. Come on. What leaders should encourage people to do is diet, exercise, personal hygiene, laundry. That's it, okay? So it's that simple. Okay, let's get back to this. We're gonna need another whiteboard, okay? So again, to recap, uh, alpha is a cardinality of natural numbers like 0, 1, 2, 3, okay? If you add some constant to this set, add 2, 2, 3, 4, 5, okay? It's not going to change the cardinality. Why? Because uh, to formally define this, I Okay. In infinity algebra, all right, this absolute value sign actually is distributive. Okay, so it's different from it's easier than this triangular inequality in infinity algebra. Okay, this absolute value is distributive. So this inequality becomes equality. Okay, so it seems to be that way. So absolute value of this guy. Okay, this is absolute value. Let's grab another whiteboard. Okay, we'll take 5 minutes break. Okay, so uh, we are making very good progress in this cardinality theory. Very good, very good. Okay, let's grab another whiteboard. Okay, and then and another thing I talked about to the two lost hours yesterday is that um, the Mr. Cantor, he is the most famous figure in set theory, but that's misguided. Okay, because Mr. Cantor, he dealt only with infinite set, all right. But set theory is a lot more than infinite sets. Okay, so yeah, Bourbaki. It's not one person. Okay, several anonymous formalists in set theory. Okay, they made a huge contribution to set theory. Okay, and also Signore Giuseppe Peano in Peano arithmetic, piano axioms. He also made a huge contribution to set theory. All right, and of course, Mr. George Boole and Monsieur de Morgan, they made tremendous contribution to set theory. Okay, so Mr. Cantor and Mr. Dedekind, maybe 10% contribution. Okay. Yeah. Okay, so there are a lot of unsung heroes in set theory. Okay, it's not about all about Mr. Head Cantor. Okay, there are a lot of more people than that. Okay, and so let's formalize this, just like Brubachists. Okay, set theory formalists. Alright, so alpha plus n is what? Absolute variable n plus n, right? And in infinity algebra, okay? That's how it works in infinity algebra. Why? We're gonna think about that later. Okay. For now, just go along with it. Okay. So, yeah, it's triangular equality, not inequality. Okay. So that's a little bit different. Okay. So now, this is what. Okay. And what is that? And we'll just put 2, okay? And set addition, okay, it's distributive, okay? That's how we just define it, okay? So 2, 3, 4, okay? The window is just shifted, right? So the cardinality doesn't change it, so this is alpha, okay? So that's that, okay? Number density doesn't change, all right? So what's number density? For example, you have window from 0 to 100, okay? And in natural number set n, you have 101 numbers from 0 to 100, right? Inclusive. Now, here we are just shifting window 2 ticks, okay? 2 to the left. Yeah, because window is just fixed length, okay? You can shift it around as long as you don't change the length of the window, okay? Yeah, then same number of integers are found in this set, right? But if you multiply, if you do 2 alpha, it becomes 0, 1, 2 becomes 0, 2, 4, 6, okay? So between 0 and 100, you can only find 50 numbers. So that's why when you multiply a set with a constant, the number density changes and cardinality also changes, okay? So this is that concept. We're not going to read too formal on this, okay? We'll leave that to other people, okay? Next generation Brubachists. That's important, okay? But now we just go along, okay? By the way, I listen to this radio. Yeah, Alaska, we have fantastic oldie channels, okay? So I ran into this oldie song, The Eagles, former member of Eagles, lead singer. What's his name? I'm gonna sing your song, okay? Yeah, all this coronavirus, don't care about it. Okay, don't worry about it. Just dance. Just like in this. Well, okay, let me sing this. They are picking up the prisoners, they're putting them in a pen, and all she wants to do is dance, dance, dance. Rebels being rebels since I don't know when, and all she wants to do is dance, dance. All she wants to do is dance. Molotov cocktail, the local drink, and all she wants to do is dance, dance. They mix them up right in the kitchen sink, and all she wanted to do is dance. Crazy people walking around with blood on their eyes, and all she wants to do is dance, dance. Wild-eyed pistols, rebels who ain't afraid to die, and all she wants to do is dance. Oh, such a beautiful song. And all he wants to do is math. How about that? Okay. Just making a pun. Alright. Let's get back. So we got that down, okay? So yeah, yeah. Very good, very good, okay. So should we erase this? Yeah, later. Okay, so if you run out of space again. Let me drink. So this computer hasn't crashed yet. Okay, so that's good. Um, so harmonic set. Each slot is same. Okay, so we just need to look at this window between 0 and 1. Okay, harmonic set H0. All right, is this. So H0 is all this, all the fractions whose numerator is 1. That's, and between 0 and 1. Okay. Well, there has to be 0 between 0 and 1, huh? But H1 is H0 plus 1. Okay? H2 is H0 plus 2. Kind of additive set theory kind of concept, okay? So, but I came up with this independently before I learned about additive set theory, okay? So, yeah, just distribute, okay? So, here you have 1 plus 1/2, 1 plus 1/3, 1 plus 1 1/4, quarter, okay, and blah blah. It's same thing, okay? So yeah, it's same. So absolute value thereof is you distributed one doesn't matter. So absolute value same, okay? So good, very good. Whew. This is cool, all right? Infinity algebra in conjunction with cardinality theory. All right, so very cool. I like this. All right. So Mr. Cantor, he asked the right question, right? And he had some good concepts down, but he didn't quite get it correctly. Okay, so yeah. So H0, okay, it's a proper subset of Q0. Why? What is Q0? All the rational numbers, all the fractions between 0 and 1. But H0 does not have 2 over 3, or 3 over 4, or 2 over 5, 3 over 5, 4 over 5. It doesn't have that. So. Okay? And H0, absolute value is what? Alpha. Right? Yeah. 1, 2, 3, 4, 5, 6, 7. Okay? Yeah. Okay? Yeah. We know that much. Now, let's try to find cardinality of Q0. Okay? Then we are done. Why? Because cardinality of Q is alpha times cardinality of Q0. Okay, so because there are alpha of them. Okay, so yeah. And cardinality of H is so you alpha within between 0 and 1 and alpha between 1 and 2 and so on. It's alpha times alpha, so it's alpha squared. Okay, and this is the disproof of Cantor's um, continuum hypothesis. We disproved it. Okay? Yeah. Yes, there are infinite sets whose cardinality is between alpha and 2 to the alpha. Okay, and also he also got it wrong. The cardinality of real number is not 2 to the alpha. It's something a lot bigger than that. Or maybe it is 2 to the alpha, but yeah, I don't know. But there's intermediary. Okay, and cardinality of rational number, I'm suspecting is alpha times alpha cube. Why? Because uh, approximately maybe alpha squared log alpha maybe. Why? Because uh, for each of these harmonic numbers, we can multiply some number, okay? And it could be logarithmic, okay? So my guess, cardinality of Q, rational number set, is alpha cube or alpha squared log alpha, okay? That would be my guess. Okay, so. Oh boy. Yeah. Because if you don't worry about intersection, if you can't allow double counting, then it will be like this, okay? 1 over 2, 1 over 3, 2 over 3, 1 over 4, 2 over 4, 3 over 4, 1 over 5, 2 over 5, 3 over 5, 4 over 5. So it becomes series, arithmetic series, like 1 plus 2 plus 3 plus blah blah to the end, alpha, right? Then what? Alpha times alpha plus 1 over 2. Okay? That's alpha squared over 2. Okay, so this becomes alpha cube over 2, something like that. Okay, so if you allow double counting, so it will be less than that because we gotta get rid of that double counted numbers. Okay, so we got big O notation down. Okay, very good. Okay, yeah. I think I need to write this down. Okay, because it seems to be very important. All right, so let me grab a notebook and start writing this down. Okay, so okay. This is a notebook I took to San Diego last year. Um, yeah, it's plenty of blank pages, so okay. I gotta write down the other stuff there too. All right. Hey. Okay. Yeah, I'm writing down everything. Three whiteboards. The proof we did a couple of days ago. DM. Sounds like per DM, right? Computer hasn't crashed yet. Good. Yeah, very good. Okay. All right. We'll take 5 minutes break and then we'll continue. Okay. Very good. All right. Okay. So what we have here is that arrange some inequality. Where is that thing? Um, just use this guy for now. So uh, we are not sure what the cardinality of Q0 is. Okay. But we do know that we know have lower boundary and upper boundary. Okay, so cardinality of Q0. We know that, right? And we also know upper boundary. Okay. Upper boundary goes like this. Okay. Let's just spell it out. So you have 2 over 1, okay, and 2 over 2, and you have 1 over 1, okay. So we call that number x, okay. So we are going to allow redundancy, right? Why? Because we want to find this upper boundary, okay. So for Q0, right? So you have 1 over 1 and 1 1 over 2 and 2 over 2, 1 over 3, 2 over 3, 3 over 3, okay. So yeah, there's some redundancy there, right? So like systematic enumeration method, it always works, okay. Yeah, you have redundancy there, here, and also here and here, okay. But we're gonna allow it. Why? Because we want to find the upper boundary for Q0 cardinality, okay. And it goes on like this, so it's like 1 plus 2 plus 3 plus 4, all the way to alpha, okay. So what's that? So this guy's alpha, right? And this guy is alpha times alpha plus 1 over 2, right? Infinite series. So it's alpha squared because alpha plus 1 is alpha, okay. Now cardinality of the harmonic set, just H, is alpha squared, okay, because there are alpha of them, right? So, and you have cardinality of Q, right? So alpha squared, which is we multiply by alpha here, okay? So alpha squared and alpha times Q0, that's cardinality of Q, right? There we go. The lower boundary and upper boundary. Okay, so my guess is kind of logarithmic, like alpha squared log alpha, something like that. Why? Because it has to do with prime numbers. Okay, I think. So we got it. I mean, we don't know the exact figure because it may be beyond our reach for now. Why? Because this has to do with prime number, I think. Why? Intersection. We gotta get rid of all this double counting, triple counting. Okay, that's very messy. All right. So we satisfy ourselves with this and we move on. Okay. We disproved Hare-Cantor's continuum hypothesis. Okay, because we found intermediate between we found identified a set, infinite set, whose cardinality is between alpha and 2 to the alpha. Okay, so we'll just satisfy ourselves with that because that's pretty big. Okay, so all right, very good. Yeah, we have multi-set. Okay, we can call this guy R because redundant. Okay, R for redundancy. All right, so yeah, we can you can transform from multi-set into a set. Okay, so yeah, I'm just waving my hand too much, so let's be a little bit more formal than that. So this set, we call it R for redundant set. It's a multi-set that allows redundancy. Okay, and if we get rid of redundancy, well, no. So this is the cardinality of this redundant set. Okay, if we get rid of, okay, good. R zero. And Q is transform from redundancy. If you transform, if you get rid of all the redundant elements, we call it transformation function. Okay, so it's input, multi-set, output, regular set. Okay, so very good. Yeah, very good. Whew. Maybe it's time to get back to the gold box conjecture proof. Why? Because this is very quantitative and we need to take a break. Okay, very physical level, very mechanical. But gold box concept is more, that's more brainy. This is very brawny. Okay, you can take a breath and just stare at that gold box triangle, whatever, right? To use our brain more than brawn. But this is really cool. Okay, I like this a lot. So, God, thank you for giving us this blessing. Jesus, thank you. I'm glad we did this. Right? Yeah. Yeah. This, ladies and gentlemen, this is just this proof of continual hypothesis. Okay. Very good. We did it. We had some fun. So Alaska is like this, okay? There are not many people here, so we are very closely knit community, and also multi-ethnic. Okay, we have African Americans, Hispanics, Asians, Caucasians, and Jews, Middle Easterns. Okay, we are very close to each other. Okay, so yeah, they don't give me any hard time just because I'm Asian in this during this Corona situation. Okay, they're very protective of me actually. Okay, so most of them. Okay, yeah, they're cool. We're like one big family here in Alaska. Okay, so yeah, we are done with this for now. Okay, so let me take a picture of this whiteboards and then take 5 minutes break and then we get back to gold box conjecture. Okay, because that requires different part of our body. Okay, it's more brain. Okay, than brawn. This is more like labor intensive, very mechanical, and very easy stuff. Okay, but gold box conjecture because it deals with prime numbers, that's that requires some creativity. Okay, and yeah, just different part of our body, brain versus brain. Okay, all right, we'll take a break. Okay, so let me take a picture though. Okay, good enough. Oh, Yeah, sorry about the long break, but I had to go to the bathroom for the second time. Uh, so yeah, yeah, Goldbach's conjecture. Yeah, I will do it later. Okay. Yeah, because I did find something very small. I will share it with you. Goldbach's conjecture. We are making slow and steady progress. Okay, just inch by inch, very slow, right? Because it's not like this. This is just, you know, we can zip through this until we run into some prime number. Okay, prime number, that's the roadblock. All right, until we hit that roadblock, we can zip through it. Okay, but when it comes to some prime number related issue, we have to stop. Why? Because that's roadblock. That's like stop sign, like cul-de-sac. I don't want to call it dead end because perhaps one day we'll overcome it. Okay, we call it cul-de-sac. Okay, yeah, just like in French, right? So let's just talk, okay? Let's put this whiteboard behind us, okay? Let's not even think about mathematics for a while, okay? So yeah, I mean, as a humanologist, okay, I subscribe to many different ideologies, okay, like anti-tattoo piercist, anti-tattoo piercism, anti-gayism, anti-sugar fetism, anti-ultra-intellectualism, and so on. Okay, but my friends, they're that. They are like tattoo piercists, gayists, sugar fetishists. Okay, whatever, right? So, but we can still be friends. I mean, we don't have to agree on everything, right? Yeah. Because nobody agrees on everything, okay? Yeah, we have. It's good that we differ. It's diversity and it's liberty, freedom, right? So it's good that we disagree, okay? Yeah. As long as we are civil, respectful, then we are fine. It's okay to disagree, okay? Actually, it's better if we disagree, okay? I'm Bacchusist, pro. I don't want to call it alcoholist, pro alcoholist because that sounds horrible. So what do? You rename it to destigmatize. Okay, all right. That's what pro gays were very good at, right? Instead of calling it sodomy or because that's too condemnatory, like in Bible days, they call it homosexuality, and later on they change it again, homoeroticism, sexual orientation, whatever, right? So I oppose that ideology, but I don't oppose people. I'm pro people. Why? Because humanology is very humanistic. We are very humane people. Okay, we don't hate people. Uh, we love people. Okay, we just oppose certain ideologies. That's it. Okay. Okay. Yeah. That cardinality theory was really cool. Okay. It was. We had a ball. Okay. Yeah. It was cool. We zipped through it until we encountered prime number. Okay. And then we back down. Okay, because prime number is like gigantic grizzly. Okay, so oh yeah, we gotta back down. Okay, so we just satisfied ourselves finding the lower and upper boundary for the cardinality of rational number. Okay, it's somewhere between uh, quadratic and cubic. Okay, most likely, I'm guessing alpha squared. I mean, yeah, alpha squared times logarithm of alpha, something like that. That would be my guess because prime number theorem. Okay, fantastic mathematicians like Muziu, Busang, and who's the other guy? I never remember this guy's name. Okay, let me look it up. Prime number theorem. Yeah, great mathematicians, right? Using like this Riemann zeta function and whatnot that I don't know much about. I know a little bit. Okay, so yeah, its implication is that prime number it's kind of logarithmic. Okay, kinda. Hadamard, Muziu, Jacques, Hadamard, Hadamard, and Muziu, Charles, Jean de la Vallée, Poussin. Okay? Yeah. Yeah, they proved this prime number theorem, whose implication, this is about prime counting function, but its implication is that prime number is kind of like logarithmic growth. Okay, and I like that. I like the result. I would admire what they did. Okay, it was fantastic. Okay, yeah. So my guess is that because we are dealing with prime numbers, why? Because it's about intersection between those the denominator. Okay, that harmonic set, harmonic numbers like one over something, and that uh, redundancy set. Okay, that we looked at. There are a lot of intersection there, and intersection has to do with multiples, the composites. Okay, and composite is flip side of primes, right? So that's why we have to stop. Okay, because it's prime number world. Yeah, that's too difficult for us for now. But hey, we found upper and lower boundary for cardinality of rational number. It's between quadratic and cubic. So, and that's the proof of disproof of Held-Cantor's continuum hypothesis. So this is something big. Okay, not as big as Goldbach's conjecture. That's big, a lot bigger project because it deals directly with prime numbers. Okay, so that's like kind of like Mountain Everest, right? So that's why we have to put it in the back burner so that we can come back to it again and again until we get it, right? But we are making inch by inch very small progress every day. Okay, yeah. I share it with you the latest findings there. Okay. So during this corona crisis, okay, Alaskans we love each other. Okay, all different races, different body types, and different ideologies. Okay, I have many friends who smoke marijuana, who are tattooed, pierced. Okay, it doesn't matter. Okay, we disagree, but we can still be friends. Okay, yeah, even yeah, LGBT members. Okay, and yes, even ultra interracialists. Okay, All different races. Yeah, mixed races, blacks, whites, Asians, Jews, Arabs, Indians. We love each other, okay? It's so beautiful. It's like when I watch them getting along, it's like paradise. It's like heaven. Yeah, blacks, whites, all different body types. Okay, big peoples, lean people. It's just so beautiful. This diversity, they're all different. They believe in different values, but they get along and smiling. It's just so beautiful. Caring, loving. In the middle of this coronavirus situation. Yeah, so Alaska to me is like paradise. Amazing and very beautiful. Okay, I'm sure it's like that everywhere in the world, right? Some parts of everywhere in the world. Okay, love, humanity, humanism. So it's good that we call this stuff humanology. Okay, yeah. I mean psychologists. They are cool people too. We love them. Okay, but psychologyism. We have some objections. Okay, they got some good stuff. I know. I took psychology class once, and it was good. I liked it. I aced it. I was on top of my class of 300 people back in Madison, Wisconsin. Okay, introduction to psychology. I liked it. Okay, but as humanologists, we have some objections of their method. Okay, so that's all. Psychologists, psychiatrists, we love them. Okay, we just object the excessive use of medicine, right? So in this coronavirus situation, yeah, and doctors, most of them are good, but some of them we have some objection because they use too much surgeries, too much medicine. Eh, okay. I mean, I had surgery when my collarbone broke. I fell from a bicycle. Okay, and yeah, they jigsaw puzzle like piece the bone together with some metal plate. Okay, yeah, some surgeries are necessary. Okay, and some medicines are necessary too. But some doctors they tend to overdo it. Okay, so we have to disagree. Okay, some of their practices. That's all. Yeah, I'm just taking a break from all that math. Okay, all that jazz, all that math, all that dance, metaphysical dancing. Okay, just take a break. Okay, let's take 5 minutes break. Okay, so I need some vocal rest, please. All right. Okay. We have like 1 hour left. Okay. Uh, I just looked up this icicle injuries. Icicle, they're so pointy. It can be very dangerous. Okay, so you better knock out all those icicles before somebody get hurt. Okay, because icicle is very pointy, right? It can fall on top of your head. You don't want that. Oh, come on. It can be dangerous. Okay, icicle. Yeah, knock it out. Okay, that's what I did. My house have some icicles. Okay, I had to knock it out because it can be very dangerous. I don't want icicle, this pointy, sharp icicle falling on the top of my head. Oh, I guess we took enough break, don't you think? Oh, okay. Goldbach's conjecture. I found something. Okay, something very small. Let's get to it. All right. Uh, all right. Let's get to it. Yeah, narcotize icicles, okay, to prevent injuries. Let's just erase this, shall we? Yeah, the remainder set, okay, the categorization of integers according to remainders, okay. If you, it's like modular arithmetic, okay. Uh, let's do this a little bit, okay, because something is really cool. All right, so some notational convention, innovation, invention. All right. Because it did occur to me, so I want to share with you, and then we get back to Goldbach's conjecture. Okay, so maybe Goldbach's conjecture like MacGuffin, term invented by Mr. Director Alfred Hitchcock. Okay, um, kind of MacGuffin, pretext, excuse, right? We're in this journey of proving Goldbach's conjecture or disproving it. Most likely proving it, right? But in the middle, during this journey, we make these encounters, right? So, yeah, some of my spiritual mentors, meaning former bosses and former teachers, former professors, okay, all different races, okay. Yeah, just enjoy the journey, okay? Don't focus too much on the result, the goal, the end. No, just while you are there, while you are getting there, that's like 90% of your life. So enjoy. Yeah, Koreans, Americans, okay, and all different country people, they give me good advices. Alright, they are very wise and smart people. Okay, most of them are older than me, but some of them are younger than me. Okay, so they're fantastic. My friends, families. How many families do you have? What I'm saying is family members. It's not like I'm married to multiple ladies. No, I'm not married. Okay. Would you marry me? I don't marry. Okay. I admire people who get married and have kids, but I'm not cut out for that. There's too much special forces too much work, too much elitism, like that's like overworking, and I don't overwork. I work, but not too much. Okay, so yeah, okay. So natural number set can be expressed in different ways. It can be expressed as odd even number union odd number, which is what natural number. If you divide by 2, even number, yeah, remainder 0, union. Odd number, if you divide by 2, remainder is 1. Okay? All that said, like 0, 2, 4, 6. Here you have 1, 3, 5, 7, blah, blah, blah. Okay? And it's also, if you divide a number by 3, remainder 0. Okay? Modulo, mod 3. Okay? By the way, this is multiple of 3. Okay? So, and if you divide by 3, remainder 1. Like 1, 4, 7, 10. Okay? And if you divide a number by 3 and remainder is 2, like 2, 5, 8, 11, okay? And let's go on and on, okay? So how do we express this in a compact fashion? You have divider, right? Divisor. So union, okay? Generalize. Yeah, we recognize this repeating pattern. It's easy, very mechanical, okay? It's pattern recognition, very easy stuff, okay? Let me grab a beer, okay? I have this one last beer in my fridge. Do you know when I panic? Not coronavirus. I panic when my beer runs out in my fridge, okay? Or vodka runs out. That's only, or my cigarette runs out. That's the only time I panic, okay? The only time I panic is when my cigarette runs out or my alcoholic beverage runs out, okay? That's the only time I panic. I'm not gonna lie to you. It's so good. Okay. Looks like my computer is doing just fine, okay? So, go ahead, fill this in, alright? Express this from. Let me give you some hint, alright? No. Your union operator meta function, okay? So like sigma pi, okay? Find the lower limit, upper limit, and the main body of this meta function, okay? We take 5 minutes break. I want to have some Hawaiian t-shirt, okay? Because it's kind of getting hot. Okay? Enjoy the sunrise. I mean, dawn. Okay? Take 5, please. Enjoy the dawning light. Morning in Alaska. Good morning. Okay. My laptop is not screaming at me. Laptop screaming is like this fan cooling down the CPU, right? Hey, it's too hot. That's my laptop screaming. Okay. Yeah, CPU it gets overheated, so I'm like, hey, chill, okay, whatever. All right. Uh, I should give my laptop some Hawaiian t-shirt because it does chill, okay. I'm a huge fan of Hawaiian t-shirt, alright. So, okay, let's go ahead and do this. How is brown doing? It's not that thick. Yeah. How about this blue? Oh, it's thick. Good. So main body contains N, right? And here's some divisor D, alright? And index I go from 0 to D minus 1. There you have it. Okay? But we're going to do something more kind of avant-garde, like Dadaism, right? Avant-garde, performance art. We'll expand our horizon a little bit. Okay? Before this, you have this, okay? You have what? 1 and 0. Why? Because 1, if you divide some number by 1, remainder is always 0. Okay, so yeah. We're going to expand our horizon of mathematical imagination here and now. Okay. It has to do with this equal sign, equality sign, all right? What if we encapsulate this? Okay? Yeah, we found this generic term using divisor, right? And this meta function, but still, yeah, we want to compact this because the two-dimensional structure is like right triangle, right? We want to compact this even further, right? It's like garbage, like algebra, the gibberish. Okay, we want to compact it, like waste management professionals. Okay, yeah, they're very good at that, right? Compacting this the gibberish, the garbage. All right, come on, let's learn from our waste management professionals. Okay, yeah, let's compact this thing. All right. Yeah, we have this general expression, but still, we wanna do better. Okay. Or maybe this is compact. Okay. One liner. Okay. N is equal to that. Because I was kind of thinking like something in the line of uh, how's this brown doing? Ah, it's too light. I was thinking more in the line of how's this green doing? Oh, very thick. Good. Something like let's make this equality as a meta function. Okay, so like n is equal to where n equality from like I from I mean divisor, right? So divisors start from one, right? Divisors is starting from one to inf- it's countable set, so it's infinity. So it's our infinity standard infinity unit alpha, right? Something like that. Okay. Okay. That's what I was thinking. Okay. Because d it can be any digit, so d belongs to integer and d is more than zero, the divisor, right? I was kind of thinking in line of this. Okay, d one, two, three, and then this guy. Uh, uh, okay, when this one, I from zero to zero, one and zero. Okay, we got it. All right. Okay. Debating between water and beer. Yeah, yeah. Just copy and paste. We're writing blue here. Copy and paste. There we go. That's what I wanted to tell you, alright? So, yeah. It encapsulates, summarizes this two-dimensional thing in one liner, alright? So, that's what I wanted to share with you. Okay? Now we got it. Because this kind of floating agent is kind of undefined, universal variable. Nah, we don't quite that. We want to define D, alright? So yeah, we're gonna give it lower limit, upper limit, and we got it. Okay? So, very good. Let me write this down. Gold box conjecture, we'll have to do it some other time, okay? Why? Enough mathematics. Systematic enumeration method. pattern recognition. Okay. Okay. Very good. Whew. Oh, it was easy, right? Yeah. As long as you don't deal with prime numbers, okay? The rest of mathematics so easy. Just quantitative. It takes time, space. Not much creativity. Okay, just rig of the roll of the rig, whatever. Okay. Yeah. Just manufacturing factory kinda very mechanical, day to day, day job kinda. But when it comes to prime numbers, like Goldbach's conjecture, for example, that's like long, long-term project, to say the least. Let me take a picture of this, okay? My cell phone, yeah, yeah. We'll take 5 minutes break, okay? Let me grab my cell phone, okay? So, okay. Is this too much for you? I mean, it's easy. Equal. Okay, we are just compacting it. Okay, like waste management professionals. Okay, to get rid of redundancy, to save some space, instead of this two-dimensional triangle, which is beautiful, we're just compacting into one liner. Okay, just like sigma plus or juxta notation, comma, or this pi multiple pi product, okay, or union, intersection, okay, just like that. Okay, why do we limit ourselves? Okay, equality, okay, you can compact it too. Okay, or inequality, whatever, right? Yeah, generalization, that's what mathematicians do. Let's compact this two-dimensional space. Let's flatten it, compact it, so that it becomes one liner. Just give it lower limit, upper limit, then you're done. Okay. Okay, let's take 5 minutes, alright? So, yeah. Some pro bono project, right? Yeah. Okay. So let me take a picture of this before I forget. Alright. Ah, boy. Good. Let me check with my friends, okay? With your indulgence. Alright? Let me check with my friends. Give me 1 second. Yeah, it's just coronavirus, you know, checking. Are they doing fine? I'm fine. Kind of thing. Okay. So we got this, right? Yeah. It's like just expanding our horizon, right? Just a little bit, right? Not too much. Okay, so that's what we did, right? We have 40 minutes left. What do we do? No more mathematics, please. Okay. gave mathematics enough service already. Okay. So we took advantage of this guy. Okay, so 3 and 0, a number set of numbers when divided by 3, remainder is 0. What is that? Yeah, multiple of 3, right? We use that this small lemma in our proof, right? That small proof that we did like a couple of days ago. Okay, so it's something really cool. Okay, it makes sense. It logically flows, right? So it's so our definition of cardinality is an improvement upon Herr Cantor's definition of cardinality because he got it wrong. Okay, bijection, one-to-one correspondence. No, that's wrong way to do it. Okay, but he started this fire, right? I mean, there's this song. Some karaoke singers in Alaska sing that song. Okay, we didn't start the fire. Da 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 da. It's a good song. Okay, I also heard that song when I was driving here in Alaska. Okay, yeah, it's a good song. But I love this song better. Okay, yeah, the Eagles, Mr. I don't remember his name. Okay, Dirty Laundry or Hotel California. He sang those songs too. Okay, I recognize his voice. Alright. How about Keanu Reeves? He was in Excellent Adventure. Okay, yeah, I remember him. Okay. Yeah, this time machine, elevator, telephone booth. I remember watching that movie back in 1980s, I think, or 1990s. I don't know. Yeah, The Matrix. Huge fan of that movie, by the way. It was a good movie. Yeah, so oh, there's this spider on the wall. I don't let any insects in my house. Okay, whenever I see it, I have to dispose of it because I don't want all this spider web. Okay, mathematics, we're done. Okay, so did I write this down? Yeah, I should write this down. I took a picture. Okay, it's digitally recorded, but still, it's not the same. Okay, I have to put it down in my notebook. Okay, I have 3 different notebooks. I did write it down. Good. Never mind. I did write it down. Huh? Okay. Oh boy. So we can put this behind us. Oh my goodness. Far, far behind us. Maybe we just sing and dance, huh? We have like 40 minutes left. I really like this song. All she wants to do is, all she wants to do is dance. My goodness, it's such a great song. Back in the days, I used to dislike this song because, hey man, why are you making fun of dancing lady? And then I realized it wasn't that. It was about being carefree. Yeah, the world is tumbling down in this coronavirus situation, okay? But she doesn't care. She just keeps on dancing. It's kind of like what we do here, okay? The world is tumbling down, coronavirus. Oh, we don't give an F, okay? All we do, all he wants to do is math. We're just doing mathematics, okay? So, oh, this is another American song. I used to go to karaoke quite a lot, okay? And there's this lady, she's Caucasian American lady, who used to sing this song. She keeps keeps. I mean, we're kind of friends, okay? So yeah, she probably is. She's in her 80s, okay? If she come to karaoke, she's quite well known local fixture, okay? Yeah, she's fantastic singer. She's yeah. Let the world go away. Put your arms around my shoulder. Is it Elvis Presley who sang the song? Let the world go away. Lyrics. Who sang this song? Eddie Arnold. Make the world go away and get it off my shoulders and say the things you used to say and make the world go away. Do you remember when you loved me before the world took me astray? If you do, then forgive me and make the world go away. A beautiful song, beautiful love song. I'm wondering, is this American song? Eddie Arnold, I don't know who that is. Okay, I think Presley sang this song once. I don't know. I'm pretty sure it's American song. Okay. Elvis Presley, yeah, he did sing this song. Maybe remake. Okay. Yeah, I'm pretty sure this American song. Okay. Mr. Eddie Arnold. Country song. Okay. Is it? I just want to know the identity of country. Songwriter Mr. Hank Cochran. Okay, he's American. Okay, what state? Mississippi. Southern. Alright. Mississippi, Tennessee. Okay, okay, okay. Yeah, it's American country song. Okay, okay. Just wondering. Is it pretty back there? Okay, yeah, it's in the morning, happy good morning. Okay, from Alaska. Yeah, we did a lot of mathematics. It's time to take a break from all this mumbo jumbo. Okay. Oh my goodness. The gibberish compaction. Oh my goodness. We came a long way. Okay. Cardinality theory. We got it right this time. Okay. Yeah. We didn't start this fire. Head Georg Cantor did. He started this fire and it's a good fire. Cardinality. Okay. Infinite set. Yeah. He's like our parental figure, kind of Abrahamic ancestral figure. Okay. And he happened to be European Jews, but yeah, mathematics it didn't came from Jews. Okay, it came from Arabs, who is also Abrahamic descendants. Yeah, you have this what's his name? The brother of Isaac, Ishmael, something like that. Let me look him up again. Oh my goodness. Ishmael. Ishmael. Okay. As opposed to Israel, Ishmael was the brother of Jacob. I mean, not Jacob, Isaac. So, Mr. Abraham, he had two sons, right? Isaac and Ishmael. Okay. So, and they're brothers by two different mothers. Okay. And who was concubine? Who was the main wife? There's some dispute about that. But mathematically speaking, the descendants of Ishmael, the Arabs, the non-Jews, they are the ancestral figure for mathematics. Like Egyptians, Greeks, Middle Easterns, like Arabic number, algebra, okay? Jews, they didn't know anything about mathematics for thousands of years. Some Jews migrated to Europe, went up north from Israel, Middle East, North Africa, okay? Then they learned from Caucasians about mathematics, okay? So, but before that, history of mathematics, okay? We'll take 5 minutes break. I break it down for you, all right? History of mathematics. We'll take 5 minutes break. Okay. I'll tell you all about it. Hopefully this computer doesn't crash. You know what? Let me stop and restart because if I don't stop, if computer crashes, all this footage is lost. Okay, so let me stop and restart. Okay, I'll see you in 5 to 10 minutes. Okay.